Okay, there was an issue with audio. Okay, so again, a very good afternoon. Welcome to the theIAShub. Okay, the main agenda of this classroom is to give you a glimpse of the geography optional basics. And today, what we are going to deal is the topic of the climatology, how the questions are asked in the climatology, and what is the syllabus, and some basic understandings a student is required before they know about the entire topics of climatology. मतलब एक कुछ basic topics है, सबको पता होना चाहिए, right? Be it your general studies student or be it your optional student, if you do not have this basic understanding, it is very, very difficult to understand the further topics, right? So today, let's look into the syllabus of the climatology. Usually, on an average, if you see, climatology say highest number of questions will be there. And this particular chapter, you cannot afford to leave without reading, right? And see, it is sizably, the syllabus seems to be little bigger also. But here, it is very logical syllabus, very, very logical syllabus. Matlab, every theory has a reason behind it. If you're studying something, it has a reason behind it. Easy to understand and easy to remember if you understand the logic. And if you fail to understand the logic, no one can help you, right? So most of the students have confusions regarding the atmospheric circulation. ये काफी important area है. If you do not understand the atmospheric circulation, you will not understand oceanography also. Climate में, this climatology basics starts from the concepts of air pressure क्या होता है, and what is wind, how is wind different from air, how is this moving wind behaves in a different manner. These things you need to know. And overall, this movement of winds, the directions, the forces that are acting upon them, and also the natural phenomena that it led to, some socio-economic impacts. That is what is the syllabus holistically. But first, let's look into the syllabus here. See, climatology mein, you see, it has near about 14 topics. Sorry, it has near about, yes, 14 topics hai isme. This entire climatology has 14 topics. You count the number of topics. If I say this has 1 topic, 2, 3, 4, and then 5, 6, like that you have 14 different topics. And all of this can be studied in a matter of 8 to 10 days. ठीक है? 8 to 10 days or maximum of 12 classes, 12 to 14 classes, ये मान के चलो. And here, everything is interlinked to each other. And there are some factual content like Köppen classification of climate, Thornthwaite, Trivartas. Ye classification of climate is factual content. Now, application of this you will also get to see in the paper 2 as well. So you learn the basics here, and climate of India also we have to study. Right? See, now entire syllabus can be divided into levels. Levels means there is an syllabus which is very, very basic. And then in this climatology, you have moderate syllabus, and you also have advanced. Okay. These are the 3 broad categories you can divide. Now, every subject has that. Look into climatology here. See, temperature and pressure belts of the world. This is a very basic. Then heat budget of the earth. It is also a basic. Atmospheric circulation. See, if you understand the temperature and pressure belts of the world, ये काफी basic knowledge है. You need to understand the concepts of pressure क्या होता है, what kind of temperatures are there in which latitudes, and then you study these temperature and pressure belts. Application of this with some forces will lead to the moderate level, that is circulation. The next topic is nothing but, you see, atmospheric stability, instability, and atmospheric circulation. Atmospheric circulation means how the winds move across the places. Is it easterlies, westerlies? Why are the winds moving in this direction? And little later, you'll get to know that there are winds which are present at the upper end, upper troposphere, where there are no easterlies, all are westerlies. So It is about when you start to study this and apply this on a moderate level, you can see the atmospheric circulation यहाँ पे socio and economic aspects of this should also be studied. Now advanced level पे क्या है? It is jet streams, right? Advanced level, you'll have jet streams. That means you have a basic level, moderate level and advanced level. And more advanced level when you start to study the jet streams and its impact. जैसे polar vortex है, अभी current affairs में है ना? You have studied about polar vortex and currently, since yesterday and day before yesterday, there is polar vortex activities which are there in the northern pole area. So, वो application that we'll be studying in the advance. So broadly speaking, you will be having these kind of 3 levels of study into the climatology. Clear? Now this is the same case. You look into oceanography also, you look into the geomorphology also. हर एक subject में ऐसे है. But for all of this, there are some basic studies which you need to know. That basic study is one such topic which we are going to discuss in the climatology. Right? See, it is temperature and pressure belts, but you need to know firstly what exactly is a pressure belt and what exactly is atmospheric pressure. What is atmospheric pressure? Can anyone define me? Can you think of defining what is atmospheric pressure? Online? So Poonam Yadav, what exactly is atmospheric pressure? So he says that the weight and mass of air. What is that weight and mass of air? Do you know that everything and anything in the atmosphere has their weight? Air also has its weight, you know. The air which you are, it has its weight. The weight of air experienced at one particular point is called as atmospheric pressure. Suppose, imagine that this is a surface, right? And on this surface, you see, you take a column, right? You take a column. And in this column, imagine this is at 0 kilometers and this is at 10 kilometers height. Let me take a point as this is point A or level A, this is level B. When I tell you there is also air in this column, don't you think that the air will also have its weight? Yes, the air has its weight. Now the weight of the air at particular level is defined as the pressure experienced at that particular point, right? So you tell me, will there be more pressure at A or will there be more pressure at B? At A. Why? Because the air above A is more and the air above B, it is less, right? So by this logic, we can tell that the atmospheric pressure is more at A and less at B, right? Now, many students across this geographical field, they do misunderstand that the relationship between pressure and temperature is PV equals to nRT. ये सब school में पढ़ा होगा, right? If the temperature is high, the pressure is low. These are some things which you have studied, but those kind of concepts, they are not absolutely applicable to the subject of geography, right? Now you got to know the atmospheric pressure. Atmospheric pressure is the weight experienced by a particular area at that particular height is called as atmospheric pressure. And remember, the sea level, imagine this is your sea level, यहाँ पे आपका sea है, ठीक है? If this is your sea, the average atmospheric pressure at the sea level is 1013 millibars. ठीक है, 1013 millibars is the average atmospheric pressure at the sea level. And then as you go higher, it will reduce. You know, on an average at 10 kilometers height, the atmospheric pressure is near about 495, 510, 550 millibars. 50% of the atmospheric pressure is present there. right? This is what. Now see, there are two different kinds of pressures which you can study in geography. That is vertical pressure belt, or vertical pressure and horizontal pressure. Or the difference in vertical pressure and the horizontal pressure, this is what we need to know. So, आपने तो ये पढ़ा होगा that wind moves from high pressure regions to low pressure regions, or low pressure regions to high pressure region. Wind always moves from high pressure to low pressure, right? This is true. Clear? Wind always moves from high pressure to low pressure regions. So यहाँ पे high pressure कहाँ पे है? Where do you find high pressure? At A. Now what should be the direction of the movement of the wind? Upward. So now what did I say? If you take any part of the earth, imagine this is your earth. If you take even this column also, here you have 1013 millibars at sea level, and here maybe around 500 millibars. You take even this column on the earth also, you'll have similar. So by this logic, the air should always be moving upright. Why is it not moving? And you see the difference of pressure here. The pressure difference is how much? I said this is 1013, and here you have 500 millibars. On an average, around mota 500, 600 alag-alag jagah pe hota hai. You know, whenever a cyclone comes, what is the movement of the speed of the winds in the cyclone? Dekho, super cyclones and all, they can cross that mark of 150, usse zyada. But lekin pressure difference usme kitna hota hai? It is around 1013 millibars is the pressure of the sea level. Sea level matlab, imagine there is a sea here, the weight that is experienced at the sea level is 1013, and the speed of the cyclone on an average it is 60 से लेकर 130 के बीच में होता है, and any speed above that it is considered to be super cyclones, right? If the wind speed is more than 65 kilometers per hour, it is considered to be a cyclonic wind, right? Now in that the difference will be hardly 1000 millibars max. If the difference in the pressure is hardly 15-20 millibars, tabhi the movement of the cyclonic wind is very, very fast. Now imagine you have a difference of 1013 to 500, near about 500 millibars. What should be the speed of the wind? हम सब भी उड़ना चाहिए, right? Are we flying into the air? No, right? See, here you need to understand two things. These pressures, no, they are of two different types. You can study this pressures in vertical pressure, and when you start to compare, if this is A and this is B, and imagine there is a point called X, there is a point called Y. When you start to compare the difference in pressure at point X and the difference in pressure with comparison to point Y, this is called horizontal pressure, right? But vertical pressure may always the difference in the pressure is very, very high. Very, very high, extremely high, but that is balanced by gravity. See, in reality, imagine if there is no gravity of the earth, all the air should go up, and it will be going. Today, you see, I told you, in the place A, imagine this is your Bangalore. The 1013 is the sea level millibars pressure, and the wind, it should go up because here 550 millibars is there. It is not always true. ये ऐसे जाता नहीं है wind. हमेशा ऐसा जाना चाहिए, but लेकिन it won't go because you have gravity on the earth. That gravity is the factor which is helping the air to stay not intact. If not intact, not to move at a faster speed. Clear? Now, if suppose if the pressure is 1013 millibars here, and if the pressure is 1000 millibars, right? Where do you find high pressure? This is Bangalore. Let's call this as Delhi. Okay, for our understanding. So the pressure is more at Bangalore, and the pressure is less at Delhi. So the wind will be moving from Bangalore to Delhi, right? And this is how the wind moves. So will the wind move like this? बट लेकिन मैंने ये कहा था यहाँ पे 1010 है तो यहाँ पे 550 milliBars मान लो. Will the wind move like this? The wind will not move like this. ठीक है. For all of this, you need some basic understandings. Firstly, did you understand what is atmospheric pressure? Atmospheric pressure is the weight experienced by the air or the collective weight of the air at a particular point. Clear? Now, once you understand atmospheric pressure, you will now be able to move ahead and study the movement of the wind. What exactly is wind? Can you define me? What is wind? How do you define wind? Yes, the movement of air is called wind. The wind can move horizontally, the wind can move vertically. Now, why is the wind moving? The wind is moving because there is a difference in pressure. If the wind from this place, it is moving to this place, it is an indication that there is difference in pressure is there, right? You need to understand the logics of pressure. Why is that pressure high? Why is this pressure low? For this, let's take a small example. Imagine you have a pocket of air. Okay. This is a packet. You have a packet of air, and then the temperature of this packet of air is 5 degrees Celsius. Right? And then what I have done, I thought of giving certain temperature to this pocket of air. Okay. Here the temperature is 5 degrees Celsius, and I have decided that the same packet of air will now be given heat. So what happens to the packet of air? The air will expand. You heat anything, it will expand. Right? Now imagine, see, in this packet of air, earlier, there is some air that is present. And here, there are some air molecules. Okay? 1, 2, 3, 4, 5, 6, 7. Like that, you have air molecules which are packed. Clear? Now let's consider this is 1 unit, 2nd unit, 3rd unit, 4th unit, 5th unit, 6th, 7th, 8th, 9th. Each unit is having certain air molecules, right? Now when I start to give that heat, what happened to the size of the packet? Usually the size of the packet also increases, right? You heat anything, it will expand. That is the general nature. So air also, when you start to heat it, what happened? It started to expand, and the size of the packet, you see, it started to increase. Right? See, now the same air molecules, they got bigger space. Okay, to be more specific, let me put it like this. Now the size of the packet is bigger. Imagine there are 5 molecules in this 1 unit. Now the same molecules can be placed at a wider distance. So आप ये बताओ, pressure, is it more in this case or is it more in this case on the air that it has? Pressure is more here, right? In simple terms, if I have to tell you, if I keep you in this classroom, if I keep 100 students, or else let's call this as, in this classroom there are 20 students, and 20 students ke liye, they can be seated comfortably. But if I put 100 more students into this classroom, what happens? The size of the classroom will get filled, and then the students might feel pressure, right? Now if I get a more area, I can fit that 100 students in an easy manner. They will be very free. They do not feel much pressure, right? In simple way, imagine in this packet of air, there are 6 molecules or 5 molecules, but now they got more space to move around. Simply, you heat anything, firstly, the air molecules will expand. The area that it got to expand. That means it will have less pressure. That means, what did you do? Temperature kya tha yahan par? Imagine the temperature is high. You increased. What is the average temperature? Maybe ये मान के चलो यहाँ पे 5 degrees है, यहाँ पे 40 degrees है. right? High temperature, by this logic, you see, you have high temperature and you have low temperature, right? What is the pressure? Pressure, here it is high. And the pressure here, right? Now the logic between the relationship between pressure and temperature. Here, when you have high temperatures, you have low pressure, and when you have low temperatures, you'll have high pressure. This is the fundamental understandings which you need to have, and this logic is applicable only to certain levels of the atmosphere. They are not applicable to every level that is present, right? Now these kind of logics are certainly applicable to geography, but they are not absolutely applicable to geography. Blindly apply nahi kiya ja sakta hai. Look, now by this logic, let's take two different places and let's try to understand the concept of difference in pressure and the movement of the wind, right? See, imagine, let me take two different places. This is place A and this is place B, right? So let's call, okay, and this is the ground, right? And both are at sea level, fine. And in the place A, you have complete air, and in the place B, you have the column of air you have taken. You are trying to understand the difference. Now let's understand, this is a place called Bangalore. Only for our understanding, in reality wind doesn't move like that. This is Bangalore and this is, you tell me another place. Okay, let's call this as a Delhi. Okay, this is only for your understanding. I'm giving different places, but in reality it won't move like that, right? Now imagine Bangalore has very high temperature and Delhi comparatively has low temperature, right? Now we are trying to understand the movement of wind, how this will move. You say Delhi to Bangalore, but what about the upper surface? Okay, let's now name this. Imagine this is your tropopause. Tropopause समझते हो ना? Huh? Tropopause is nothing but a layer or the topmost layer of the troposphere, right? Earth has various layers. If you take this Earth, it has troposphere, stratosphere, mesosphere, ionosphere, or thermosphere. So tropopause is a layer which is present on the topmost of the troposphere, and that is the place where the temperatures are more or less the same. Now come back. This is the tropopause, or it is the height of this tropopause is around, on an average, ये मान के चलो 12 kilometers दे देते, ठीक है? It varies from 18 kilometers to 9 kilometers. 18 kilometers it is near to the equator, and 9 kilometers to 10 kilometers at the poles, right? On an average, 12 to 13 kilometers is the average height. Now what are we trying to do? We are trying to understand the movement of the wind here. Now imagine the total amount of air that is present in this particular, the total amount of air present in the column of Bangalore is 100, ye मान के चलो, and total amount of air present in the Delhi is also 100 units. So here you have 100 units of air, and here also you have 100 units of air, right? Now as this is a low pressure area, what about the wind? The movement of the wind should be from high pressure to low pressure, right? In reality, in reality, how will the wind move? The wind will move whenever there is movement or pressure variation. So imagine that there is low temperature here. Sorry, it will be high. Okay, low temperature there, and this is high temperature. As the temperature is high, the air will start to rise. ठीक है? यहाँ पे the air will start to rise. But why is this air rising? ठीक है, ऊपर low temperature है. You apply the logic to the same column here. देखो, let me tell you one more thing. Before this, you need to have an understanding of the concept of lapse rate. Lapse rate matlab, it is a rate at which the temperature reduces as you go higher into the atmosphere. Imagine that this is the surface of the earth. You go 1 kilometer into the atmosphere, the temperature is reduced by 6.5 degrees Celsius. You go 1 more kilometer, again, plus 6.5 degrees Celsius, it will be reduced. The lapse rate is 6.5 degrees Celsius. Now imagine that at the Bangalore, your temperature is 40 degrees Celsius. What will be the temperature at the tropopause? It is less than 0, it goes into minus 30. ठीक है, minus 30 तक, around minus 10, minus 15, 20 तक जा सकता है, right? That means always the temperature at the tropopause is near about minus 10, minus 15, minus 20 होता ही है. At the surface you have high temperatures. Now if you try to apply the same logic, sir, यहाँ पे तो temperature low है, यहाँ पे तो temperature high है. The wind should move from low temperature to, high temperature to low temperature because of the changes in the pressure, as per the logic which I have told you. That kind of logic will not work in geography. You need to think in a different way, right? You need to have an idea where you can visualize why is the wind moving, what is the circulation that is happening. Simply put like this, imagine this is, both the columns are having 100 units. In the low pressure, wherever there is high temperature, you will have comparatively low, just a minute. You will have low pressure. This is what you have learned in the previous slide, right? And then here you have high pressure. Okay. Now see, in the low pressure zones, usually the air starts to rise. Suppose if there is heat here, if the air starts to rise, don't you think that entire air goes up into the atmosphere and there shouldn't be any air so that you cannot breathe? It should happen like that, right? See, that kind of case will be there whenever there is a closed system. Okay? Imagine in this room, I will not let any air to come out or any outside air to come into this room. In such a situation, the air can move up, right? And there won't be any more air present at the surface. But our earth is not a closed system. Our earth is an open system. Open system means, in simple terms, if I have to tell you, you look into the atmosphere, earth, the winds move from anywhere to anywhere. It depends on the pressure belts. Come back here. In this 100 units, usually in the low pressure system, what happens is that the air will start to rise. And you see, out of this, of the total 100 units, in the low pressure system, most of the air is actually present near to the tropopause, and there is less air molecules present at the lower end. Okay? Most of the air is present in the upper heights and less air is present at this end. But when you take the high pressure area where the temperatures are very low, in this case, most of the air, it is present at the lower end. And less air will be present at the higher end, right? This should be very clear for you. Now here, forget the concepts of temperature and pressure for some time. Look, this region is having high pressure. It is because there is more amount of air molecules are present at the lower end. And in this region, it is experiencing low pressure because there is less amount of air present at the lower end. As the air starts to move up and packs there, collects there, there is a gap that is created. Gap in the sense, there is air, absent air. That air will be filled by the more air molecules which are present here. They slowly start to move into this region. In simple terms, if I have to tell you, imagine you have 100 units of air, right? In this, maybe 20 units of air are present here, and rest of the 80 units of air is present in this region, right? But in this case, maybe 15 units are present in this region, and rest of the units, that is 85 units, are present in this region. It can be like this, right? So by this logic, you tell me, how will the movement of air be only in the Delhi? It is from high to low, right? But like, where is high pressure? No, just see, firstly, I know you are not able to comprehend this because you have learned the relationship between pressure and temperature. It should not be like this. Remember, you should always compare the difference in pressure at the same height. In this, there can be equilibriums. But for our understanding, we'll come to the equilibrium point little later. But see here, you should always compare the pressure at the same height. You should not compare it like this, or you should not compare like this, in this way. Now, you see, between the place Bangalore and Delhi, where do you have high pressure? At the surface. Delhi, this is high pressure. The wind always moves from high pressure to low pressure. So, always the wind will move like this. Right? It has reached here. Same is the case. It is low pressure. There might be another column. Jahan par again 80 units of air is there. So it starts to move in this direction. Right? And look at the difference in pressure between Bangalore and Delhi at the tropopause at a height of 9 to 10 kilometers or 12 kilometers height. How will the wind move? From high pressure to low pressure. You should not compare in this way. The relationship between temperature, always the temperature is low at tropopause. ठीक है, tropopause पे temperature low होता ही है. If you find that logic, you will fail to understand these concepts. Now see, now here the wind will start to move in this direction. And then it sinks. Same is the case. All the air molecules, it's sinking, and there is much of the air molecules are present at the lower end. That's the reason why you will find they are to be heavier, right? This high pressure is high because all the air molecules are coming down. Now, do you find a cycle, the air that has risen here? Low pressure area mein usually the air rises, right? Don't you see the same air making a big circle? One full cell it has made. Why is it making a one full cell? It is because initially there is a low pressure system here because of heat, high temperature. As the temperature is high here, there is low temperature. Because of that, the air started to, the temperature is high, the pressure is low, the air started to rise. As the air started to rise, there is a gap that is created. What is this gap? Earlier, this entire region should have 100 units, where 50 units are here, 50 units are here, equally distributed in an equilibrium condition. But now, much of the air has moved up, it created a gap, and that gap is being fulfilled by the air high pressure which is present here. Whenever this full cycle completes, in this cycle, until it attains to an equilibrium, this cycle continuously keeps on flowing. Now, this is how the movement of the wind takes place, right? Clear? So, these kind of wind cycles and movements are dependent upon the pressure system, right? ये सब pressure system के ऊपर depend करता है. And rule number 1, here you have learned that the relationship between temperature and pressure is only applicable to the surface levels. Up till 3 kilometers तक you can apply. If you apply the same concept, अगर temperature high है, pressure क्या होगा? Low. If the temperature is low, pressure क्या होगा? high. Apply the logic between the temperatures between the tropopause and here. What is the temperature? We considered it to be 20 degrees Celsius or 30. Here the temperature is. Apply the same logic. Apply the same logic here. You'll get confused. So always you should compare. If there is minus 15, this can be. Okay. It can be minus 10 degrees Celsius. You should compare the temperatures at the same height, pressures at the same height, not vertical. Vertical pressure will not be successful when you apply the same logics, because vertical mein there is gravity. Gravity balances, right? That is why, in spite of the variation of the pressure is very, very high at the surface. यहाँ पे 1013 है, 550 है, but लेकिन in this condition, everything that is present at the surface, it has to go up. It is not going because we are having a concept of gravity. That's why the logics of temperature and pressure, it is not always applicable in these conditions. Now, if you understand this concept, once you understand this particular cycle, it is very, very easy for you to understand the further topics of geography, especially in the climatology, right? Come back. Now we will move ahead to learn another concept, that is pressure belt. Okay? Pressure belts. Once you learn the pressure belts, you have to apply the same concepts onto those pressure belts and certain forces that are there, Coriolis force and all. Those forces, when you apply, you'll get to understand very, very easily. In the main classes, we'll learn about the forces and the reasons why the wind turns into right, why the wind turns into left in the southern hemisphere. Here, these are very basic things that we are going to tell you. So, Coriolis force explanation, I'll be giving it in the further classes, not today, right? So, broadly speaking, our Earth has pressure belts. Okay? If you see, if this is the Earth, the highest temperatures on an average, you know that Earth will, at the equator, the sun rises more or less, sun rays is more or less vertical all throughout the year, near vertical if not vertical. And on an average, collectively, you look at the equator, it has high temperature. You look into 23 degrees latitude, 23.5 degree Tropic of Cancer, this is Tropic of Capricorn. And then you have Antarctic Circle, you have Arctic Circle, right? At the Tropic of Cancer, you have 3 months of summer and 3 months of winter. Here also, 3 months of summer and 3 months of winter. Cumulatively or collectively, if you look into the temperatures are high at the equator. यहाँ पे summer winter होता ही नहीं है. All through the day, it will be hot. In the evenings, it will have rainfall, and next day morning again it will be hot. रोज बारिश होगा, रोज गर्मी होगा, right? Thick vegetation is there. It is a different type of climate which is there. Now, because of that, if you look into the pressure system here, what kind of pressure it should have? It has low pressure. And this is called as equatorial low pressure, right? Equatorial low pressure system. But compared to the equator, you compare it to the subtropics or tropics. There the temperature is low or high? Low? Yes, temperature is low. But see, this particular area is not induced thermally. Why is the pressure low here? What is the major reason? Yes? High temperature. That means the high direct sun rays, that means temperature is the sole factor which is deciding what is the pressure belt that is present here. But यहाँ पे ना, temperature is not the sole factor which will be decided. There are multiple other roles. Now, any pressure belt, if it is formed because of the temperature dominance, that pressure belts are called as thermal or thermally induced pressure belts. Likewise, you go to the polar region. ठीक है? You go to the polar region. Polar region में it is always cold. Be it summer, summer में भी the temperatures are almost 2, 3, 1, -5, -10. Even in winter it will go to -30. Right? Temperature is extremely low all throughout the region. So, as this particular area will be having low temperatures, so that's why it will be having high pressure. And this is called as polar high pressure. Polar high pressure belt. Now this is equatorial low pressure belt. Now these two belts are dominantly induced by temperatures. But your polar belt may dominant reason is temperature, but there are also some other factors. So that's why we also call this polar belt as thermally dynamic belt. ठीक है? It is thermally induced, no doubt. Temperature is the prime factor, but कुछ dynamic factors भी है. Right? But you look into the rest of the pressure belts. Rest of the pressure belts are present at subtropics and subpolar. Now compared to the polar region, do you have high temperature or low temperature here? You will have comparatively high temperature. Now the pressure that will be present at this particular area as compared to the polar region will be low, right? So that's why it is called as subpolar low and this is called as subtropics high. Now why is this high? It is because in comparison to the equator, right? Now here simply these two belts are formed because of dynamic reasons. Dynamic reasons, more than one reasons. They are forcefully formed. Permanent pressure belt systems are the one which is at the equatorial low pressure system and at the polar high pressure. Rest of the two, they are called as dynamically induced. There are many reasons why are they formed. So those reasons and all we'll learn in the further classes. Today, if you try to apply the same logic, more about the pressure belts, I'll explain in very detail about each pressure belt in the further classes. Today, you try to apply the same logic here of the pressure belts or the logic of movement of the winds, high pressure to low pressure, right? Come back, see, imagine this is a low pressure area. Now this low pressure area, the air will start to rise. Until what height it rises? It can rise up to maximum of 18 kilometers क्योंकि 18 kilometers तक यहाँ पे tropopause होता है. Because of that extreme heat, the air has risen. Once it has rises, ये मान के चलो ये आपका tropopause है. ठीक है? Now the air will start to diverge. ठीक है? The air starts to diverge. The diverged air will now start to sink. Right? You understood the concept, right? See, this is high subtropical high pressure belt. Now look into the high pressure area. This is your high pressure area. What happens to the air here? Sinking. Now apply the same logic here. It is sinking air. The air will start to sink and it makes a cell. Okay. Now the air which is moving at the surface, it is this. Right? Same is the case in the southern hemisphere too. Right? Like this, there are cells. Now the air is moving here. The movement of the air, it is also moving here. On the entire earth, the air moves on the entire earth. It is not just on the, if I'm drawing a diagram like this, it doesn't mean like the air has risen and then it is like this. It's not. This air, it tries to, these kind of system of air, it rises away from the board, then goes, sinks, and then travels. Clear? So by this logic, the wind direction is dependent upon the pressure belts that are formed. Now here you have a force called as Coriolis force. Now the role of the Coriolis force is like this. So a Coriolis force is generally believed that because of anything that travels in the northern hemisphere, okay? The reasons for this I'll be explaining in the further classes, but understand anything and everything that floats, that moves into the air, be it your aeroplane, be it your wind, be it your ocean water, they will be deflected towards the right. Right? If suppose there is something which is going in this direction, it will be deflected towards the right. The resultant direction will be like this. It will not go in the same direction, but it does move in this direction. Right? If suppose there is something which is traveling in this direction, the resultant movement will be like this. If it is moving in this direction, the resultant movement towards the right, it will be like this. Similarly, if something is moving in the northern hemisphere, its resultant direction will be like this. Why and all, I'll be explaining this in the further classes only. Similarly, in the southern hemisphere, anything that moves or floats, its deflection is towards the left. Okay? So imagine if something is moving in this direction, the deflection is like this. It is like this. If it is moving in this direction, the deflection is towards the left. It is like this. Right? So this is how the deflections are. Now the similar kind of deflection you will also see in the wind system as well. You look here. Now apply the deflection towards the wind that is moving on the northern hemisphere. Towards its right. So you tell me, will the wind move in this direction or in this direction? Let me call this as A and let me call this as B. Online? Yes? A or B? Indu will tell us. A or B? A, right? So, this is how the wind movement is. In the southern hemisphere, if the wind is moving in this direction, will it move, this is A, or will it move in this B? A or B? B, right? The deflection is towards the left. So, the wind does move like this. Now you see the direction of the movement of the wind here. Suppose, let's take this wind. This is north, this is south, this is east, and this is west. What is the direction of the movement of the wind? It is like this. Right? The wind seems to be coming from northeast in simple terms. Right? So these are called as northeasterlies. Okay? They are called as northeasterlies. Then what is the direction of these winds? South easterlies or southwesterlies? ये check करो. Suppose this is north, south, east, and west. The direction of this is northeasterlies. What is this direction? Yes? Is it here or is it here? How do you draw? These are southeasterlies. Okay? These are northeasterlies, these are southeasterlies. Southeasterlies because in the southern hemisphere, they are also coming from the east, they are also coming from the east. It seems to be coming from the east. And these winds, you see, they just do not stop it here. They go, it's like this. To be more specifically, the winds again, they come back from the other end. All throughout the earth, they go around. And these are also called as plus planetary winds. Suna hai? They are also called as planetary winds because all throughout the year they are present on the planet and they go around the planet. That's why they are called as planetary winds. Okay? And these winds they also change their direction in some areas. They are called as trade winds. It is these winds, they get the monsoons to India. You will study the monsoons in very detailed manner in the further classes. Now, this is the basic understanding one should know in the climatology. The same kind of logical applications when you start to apply it to the subpolar cell, polar cell, then the direction of the wind is completely different. Let us try to apply the same thing to the direction of the wind in the subtropical belt. See here, what is this low pressure belt? Low pressure belt pe kya hoga? What happens to the wind? And then it diverges. Whatever the air that diverges, it do not diverge in single direction. It is like this. So what is the direction of the wind which is flowing in this direction? What is the right direction to it? Is it correct? Do they look, are they coming from the east or are they coming from the west? अगर किसी को east और west नहीं पता, always remember, see, many students, it's okay, this is your east and this is your west, right? So look, they seem to be coming from west direction, and these winds are like this. They are also, they go across the planet and then come back. They are nothing but westerlies. These are northwesterlies, right? The direction of the wind will tell you what are easterlies and what are westerlies. If they are coming from the west, they are westerlies. If they are coming from the east, they are called easterlies. If they are in the northern hemisphere, they are called as northeasterlies. If they are in the southern hemisphere, they are called as southeasterlies, right? यहाँ पे क्या है? East, west, north, south की खेल है. If you understand this simple concept, rest of the climatology is a cakewalk, right? यहाँ तक कोई doubt? Yes, all clear? So like this, the first concept that you need to know is this pressure belts and the direction of the winds. Now this easterlies direction, whenever you learn, the advanced topics in this are jet streams. Now what is this advanced? Where are these jet streams present? See, the jet streams are present between two cells. You got to know that this is one cell, this is another cell, this is another cell. There are names given to these cells. What is the name of this cell? Hadley cell. This is polar cell. You have names of the cells. Clear? ये तो आपने geography मेरे से पढ़ा होता आपको पता है. But if a student who is learning it for the first time, it is a very difficult topic for them. In the NCERT also, it is written in a very small manner. And then first time when they study, ऐसे देखे या ऐसे देखे पता नहीं चल रहा है. ठीक है? There's a lot of confusion all around because fundamentally issue is that they do not study this properly. They study it, अरे high pressure ऊपर है, low pressure इधर है. तो mostly students do confuse, they get confused here. Sir, how come there is low pressure here? And how come there is high pressure here? Sir, if there is high pressure, यहाँ पे भी high pressure होना चाहिए, right? यहाँ पे low pressure होना चाहिए. But why is this high pressure here? It is because you see it through a different lens. When you see it through a right lens, it is easy for you, right? Come back. Now here, the concept of jet streams comes into picture. Now you got to know that this is your Hadley cell, this is your Hadley cell, and this is your Ferrel cell. Between Hadley cell and Ferrel cell, here you will have jet stream. ठीक है? Here you will have a jet stream. Now these jet streams are three-dimensional entities. ठीक है? They will have a length also, they will have a breadth also, they will have a height also, and they travel at a height of 9 to 10 kilometers. It is near the tropopause, right? And these jet streams, while they travel across the earth, they change the weather patterns. And one such weather pattern which is in current affairs today is polar vortex. Polar vortex हमेशा ही होता है. These kind of vortex are present in the North Pole also, they are present in the South Pole also. ठीक है? They are always present. But they get weakened during the summers and they are strong during the winters. Sometimes whenever they get weakened, The cold winds, they come all through the little lower height, altitudinally, latitudinally, and it creates some havoc. Its weather influence can also be there on the surface. That's why you open the newspaper yesterday and today, the newspaper talks about polar vortex. That polar vortex is an advanced topic. To understand that, you need to know this. You need to know about jet stream. Jet stream क्या है? एक three-dimensional entity है. That three-dimensional wing, it keeps on moving in the atmosphere at a height of 8 to 10 kilometers, and then when it starts to move, it changes the weather patterns. It does move like this. Just a minute. This is how they are present. It's like a pipe. And you know, during the Second World War time, most of the countries, they're not aware of this. So if Russia wants to attack another country, or if US wants to attack another country, what they used to do is, they were not aware of this, and accidentally they got to know about that. This jet streams mein, they got to enter, the flight got to enter into that, the warplanes, and they traveled very quickly without their knowledge. And then they understood, okay, these winds can move at a speed of more than 300 kilometers, 400, 500 kilometers. And if an aeroplane is put into that, it is moving faster. So that is how the jet stream study started to happen, and slowly, little later, the applications of this jet stream is still not completely understood. The formations of the jet stream is still not completely understood. Only there are certain theories which tries to justify how these jet streams are formed. See, any movement of the wind is dependent upon the difference in the pressure. If there is a high pressure and there is extremely low pressure, the wind speed is more. There are some other factors, those factors again we'll learn. Now, if you study this jet stream, these jet streams and their formations and their applications are considered to be studied under advanced geography, which I have told you here. Right? Basically, you need to know about temperature and pressure belts. Once you know, apply it, and that application is nothing but the winds. And once you know about the winds, you need to study the advanced topics. Now, like this, in climatology, there are 14 topics. Out of these 14 topics, now it broadly needs an understanding of few particular basics. Agar aapko basics pata hai, then you would be easily able to handle it. Now, let me show you the syllabus again. Temperature and pressure belt of the world, number one. That means it is nothing but you have to study about those 7 different types of pressure belts. Heat budget, right? Atmospheric circulation, how the movement of the wind is taking place, that is what we have discussed in a brief here. Atmospheric stability and instability. Yes, stability or instability hota kya hai? What is atmospheric stability? Yes. If there is a cyclone, is it a stability or instability? Stability. Instability. If there is a rainfall, it is again instability. If there is a clear sky, it is stability. Suppose, whenever you have a clear environment, clear sky, sunny day, clear sky is there, where you can see the stars and all, that is called as stability. Instability is anything in the atmosphere when it gets disturbed. Extreme cloud formations, extreme rainfall or normal rainfall, cyclonic system or temperate cyclones, tropical cyclones, these are considered to be studied in the atmospheric stability and instability, be it the formation of fog, be it the formation of temperature inversion. All these things will be studied here. Next, planetary and local winds. Again, the same winds which we have studied, we have to go into the little more detail. Kabhi aapne suna hai nor'westers, mango showers, blossom showers, Kal Baisakhi. You will be studying about them with respect to India. Sea breeze and wind breeze, what are they? These are nothing but local winds. There are different names to these winds in different places of the world. You have to study about that. Next, monsoons and jet stream. Yes, this is an advanced topic. Monsoon, ek jagah you will not get the entire content. You have to accumulate in the classroom itself. There is no book till date which has done justification to the monsoon topic. So you have to completely depend on the classroom itself, monsoon and the nodes of the monsoons. And monsoons mein, there are old theories and there are modern theories. Modern theories, it talks about jet stream theory, El Nino, La Nina, Indian Ocean dipole, all these current affairs you might have heard. That is where you will study. And coming to the air masses. Air masses means when you have a big area, imagine that you have a big area as big as the size of the small, this size of area, when it has uniform temperature, uniform pressure in this area, that is considered to be an air mass. Like that, you have multiple air masses. Sometimes these air masses interact. Whenever they interact, they will create some kind of rainfall, thunderstorms, clear skies, those things we need to study. That is nothing but your air masses. Temperature and tropical cyclones, very easy topics. Types and distribution of precipitation. How the precipitation happens, what are the different types. There can be rainfall because of convection. मतलब शाम को कभी अचानक से बारिश होता है. Usually, at what point of the day you have the highest temperature in that air, atmosphere? Afternoon, what time? 2 p.m? No. It is between 3 to 5 p.m. की बीच में हो सकता है. Usually it is 3 to 4. In some areas it is 4 p.m. See, the sun is directly overhead around 12 p.m., 1 p.m. But the atmosphere will take some time to get heat. Okay? It is not the incoming solar radiation. The sun's rays is not heating your atmosphere. It is actually the sun sending its rays and it is heating the earth. The earth gets heated and the earth will start to radiate heat. It takes some time. It takes some certain time. Usually it is between 3 to 4 p.m. And that is the time period most of the times during the summers. Abhi 2 mahine ruk jao, hardly this is the month of February end, March end, and in the month of April you will be seeing this kind of rainfall in India. Be it in the Karnataka it is called as blossom showers, in the Kerala it is called as mango showers. They are nothing but convectional rainfalls. Matlab, from morning to evening there is intense heating and all of a sudden in the evening there will be rainfall. That is nothing but convectional rainfall. So usually this convectional rainfall will happen at 4 o'clock. ठीक है, शाम को thunderstorms, lightnings, you'll get to see. So all these are aspects of the different types of rainfall. Precipitation kya hai? You need to study about them in detail. And there are some factual contents. Köppen and Trivarta's classification. How does Köppen classify the climate? Factual content, very easy. And then hydrological cycle. It means the water that evaporates, it changes its form. The evaporated material, it gets into the clouds, and clouds, it precipitates in the form of rainfall, in the form of snow, in the form of sleet, dew, mist. Alag-alag tarah, you need to study about them. Then global climate change, ये सब application part है. ठीक है? Global climate change and the role and responses of man in climate change and applications of urban climate. आजकल आपने ये सुना होगा urban heat island, right? Urban heat island. That is nothing but applied climatology. Urban heat islands, extreme temperatures in the continentality, right? Very high temperatures in the cities, and when you go out of the cities, it is less. Heat dome suna hai? Heat dome in the current affairs. That heat dome, all these things will apply it here. So broadly speaking, if you look into this, your climatology topics, it is like this. Most of the topics jo hai na, they are 90% of your syllabus. 90% of the syllabus is present here. If this is your earth, right? And you see, imagine this is 10 kilometers into the atmosphere. You are actually studying what is happening in this area and its impact on the earth. Why are they happening? What is its impact? This is nothing but climatology. Clear? ये थोड़ा practically पढ़ना पड़ेगा हमें, and anything that you can Usually it is understood through diagrams. Just draw the Earth's diagram and wind movements, and this is the area where the examiner cannot take away the marks from you. Usually what do they do is, students study so much of geomorphology. By studying geomorphology, you spend near about 1.5 to 2 months. And within no time, you will understand that geomorphology mein to the weightage, return on investment is very high. What you have to do is, we have to study climatology as well as oceanography in detail, and then the number of marks collectively by studying climatology and oceanography, if we can attempt all the questions there, you will get an additional 10 to 15 marks, which can give you a leverage of you getting into the service. Right? And this is what is about climatology. Koi doubt hai? Online, offline? What's my contact number? Sajjan. See, this is my contact number and this is my name. Okay? And Namaskaram Sajjan. Yes, he's saying Namaskaram. Okay. Agar aapko koi doubts ho, you can just drop a message, but no calls, please. Okay? Drop a message, and if it is not clear, then I'll give you a call back. Come back. So, broadly speaking, this is what is climatology. And you need to have a clear-cut idea of what are you going to study in every chapter. ताकि आपको ये पता चलेगा, अरे यार, we are going to study about this. Then you will also try to frame your mind accordingly. Else what happens is that, हाँ, मैं geography optional ले लिया, and then you have come here citing that I'll study these books. It's not, you won't able to comprehend them in a better manner. First, you need to have a superficial idea about what exactly this topic is. Right? Only then it will be very, very easy for you to understand the further topics as well. Clear? And once you studied this climatology, from climatology onwards, you'll enter into the oceanography. Climate आपने पढ़ लिया, ठीक है? Now the formations of that climate at a particular area is because of the sun, solar, and then it is also because of the ocean as well. Your ocean will decide what kind of climate will be there. So, application of climatology, you will also apply it on the oceanography. These two are sisters to each other, right? And when you study the geomorphology, climatology, and oceanography, your base will be complete. Upon this, you keep on adding the content, social angle, economical angle, political angle, applications of these landforms. So usually it is actually, the subject is called technical because, see, these subjects are interlinked. Ye तीनों ना, if you miss out 10 classes out of this, you will not be able to understand it properly. So, agar aap, when we collectively complete these topics, rest of the geography is a cakewalk. Okay. What do the mistakes that are done by many of the students is that they think that yehi hai geography. Ye jo geography part hai na, this is only the weightage of near about 20 to 30% of the marks. But rest of the geography is human geography. We have to also focus there. In the last class also I told you, right? Clear? So ye hai, this is the strategy we will be following, and for every topic, notes will be given in the classroom itself. And if you have any doubts, all the doubts will be addressed here. Abhi tak, whatever we have discussed, isme kuch doubts hai? One doubt is that Vipul asked, sir, can there be an equilibrium in these conditions? ठीक है? He asked me a doubt, sir, can there be an equilibrium? Yes, there can be. Ideally, there can be equilibrium, but in reality, equilibrium is very less likely. But can exist, equilibriums can exist. Anything online, any doubts? Thank you, Chinar. My name is MD Ayub, CSE. Okay, so today we'll end the class here, right? And again, day after tomorrow, we'll continue. If you have any doubts, you can drop a message to me. You have my contact number, right? And see you in the next class, right? Online, if you do have any doubts, you can drop me a message too.